In this video, I'm going to talk about diazonium salt chemistry and benzene derivatives. Okay, so remember we talked about this. Okay, remember we talked about benzene derivatives, and we're just putting add in substituents on the benzene ring. Okay, now remember we spoke about this. We said that okay, well, how would we make this? Well, again, I see this is a meta director. So this is meta director. Okay, meta director. We know this is a ortho para director. And so we know that this is simply easy to make. So if I want to make this from benzene, well, I could simply take benzene. I know that this is a para director. Well, we're just gonna not include ortho since they're para to each other. So we know the CH3 is a para director. So the idea is that we could simply take CH3Br, okay, and add in some sort of Lewis acid, okay, and we get or CH3, okay, and we know this is now a para director, and so the idea is that I could just nitrate with nitric acid and sulfuric acid, okay. We could do that, and then we just get our simple product. Okay, so whenever CH3 and it goes, the nitro group goes in the para direction. Okay, but what if we're given a molecule like this? Okay, and I usually look at these as some awkward orientation. Okay, what if I'm given a molecule like this to make? Well, if you look at this, I want you to notice something here. These are meta with respect to each other, but they're both orthopara directors. So this is an orthopara director, yeah, and this is an orthopara director. And so this is what I call kind of an awkward orientation. Notice that in this case we had a meta and para. Okay. In this case, they're meta with respect to each other, but they're both ortho and para directors. So how do we handle that? We can't just put on the bromine, okay? But because we know the bromine will be an ortho para director, so we'll not get the CH3 in a position that we want. Likewise, we could put on CH3 first, and again, it will give us the same problem. So this is the idea that we gotta use diazonium salt. I'm gonna bring in the idea full forward here. So what if I want to synthesize this molecule from benzene? Well, if I take benzene, okay, if I take benzene, well, which one would I add first? Which one would I add first? Well, because they're para, because they're meta with respect to each other. We know a good meta director, and it's that nitric group. So if we nitrate first, this is nitric acid and sulfuric acid. Okay, we actually get the nitric group. Okay, now where will I put the nitric group? I'm just gonna put it where I'm gonna create my diazonium salt, and this might seem unclear to you at first, but again, I'm gonna clear it up at the end to show you why, and so you could kind of just rewind the video and kind of practice these. Okay, so I'm gonna put the nitric group where I'm actually gonna add my bromine, and so this will be my NO2. Okay, now because this is a meta director, I could go ahead and add my CH3. So I could take CH3 chlor and a primer, just a alkyl halide, yeah, and I add aluminum trichloride, and I'll create my CH3 in the meta position. Okay, I have my CH3 here, I have my nitric group here. Okay, now the idea becomes I have to reduce my nitric group to this NH2 group here, and again, pick a reducing agent. I typically use sodium borohydride. Okay, and so what happens is that you could actually get the NH2 group first, the NH2 group here. Okay, and then I still have my CH3 here, and now we create diazonium salt from this. And the diazonium reagent is that you're going to use sodium nitrite. You're going to use sodium nitrite, NaNO2 in HCl. Don't get this confused with nitrate. Okay, this nitrite NO2. So this is the diazonium salt reagent, and what it does is that it actually generates. Okay, so we still have our CH3 here. It actually generates this NH2 group here to be an N2 plus. Yeah, so it will become an N2 plus Cl minus. Okay, so this is the general formula we'll generate from this NH2 group here. And the idea is that now we could just add Cooper's bromide, okay? and we get the bromine. We get the bromine in that position. So we have our CH3 and we have our bromine. Okay, so this is how we synthesize the molecule. Now, the general procedure. If I have aniline, okay, or any NH, yeah. So if I have aniline, okay, and I add sodium nitrite in HCl, I'll generate the diazonium salt. So we have N2 plus and Cl minus. Okay. Now from this, I could get a plethora of compounds. So if I take this and I add sulfuric acid and water, I'll get phenol. Okay, I'll get phenol. Now if I take this and add cuprous iodide, I'll get the iodide compound. So we get the iodide. Okay. If I take the same molecule and add cuprous bromide, we just did it, we get the bromine. We get the bromine on the ring. Okay. So we get the bromine. Okay. And by the way, diazonium salts are very unstable. They're very unstable, and so that's why you can't, we typically don't isolate these, because they're very unstable. It's because of this nitrogen compound here. Okay, so we talked about H2SO4, cuprous iodide, cuprous bromide. Yeah. From this, okay, so from this, if we add cuprous chloride, we get the chlorine on the end. Yeah. So we get the chlorine there. What else? Yeah, so I could take this and add, this is the reagent, HBF4. So if I take this molecule, the diazonium salt, and add HBF4, actually we get the fluorine. Okay, I'll get the fluorine compound. Yes. I could also get the cyanide. So let me redraw the diazonium salt. So from this, N2 plus Cl minus. If I take this and add let's see, if I add cuprous cyanide, yeah, if I add cuprous cyanide, then I'll get the cyanide group on the benzene ring. Yeah. I could also take this and add potassium iodide. Actually gives you the same iodide on the ring too. Okay, so that gives you the iodide. Now what's interesting is that if you just want the pure benzene, you could use this reagent. It's H3PO2. Okay, and actually that will just generate the hydrogen. Yeah, this is a hydrogen. Actually, that will just generate the hydrogen on the ring. Okay, so these are all the different reagents that we have to use at our disposal. So let's look at another one. Let's make this. So let's make this from benzene. Now that we fully know what I was talking about initially. So what if I have this molecule here? What if I wanted to make this molecule from benzene? Okay. Well, again, they're meta with respect to each other, but they're both orthopara directed. So this is kind of the awkward orientation that we kind of talked about. And so we know a great meta director, and it's that nitrate group. So the first thing we're going to do is nitrate. So if I take this from benzene and I add sulfuric acid and nitric acid, yeah, I get, if I take I get the nitric group. Okay, I get the nitric group. So this is NO2. Yeah, and we know in this case it doesn't matter where I put my NO2, because I could use any, with the diazonium salt, I could use any one of these to get any one of these. Yeah. So, but in the previous case when we talked about this one, again, we know to get diazonium salt for bromine. We don't know about this R group here. But in this case, if you notice, we have iodine and phenol, and this alcohol here, not phenol. But what we just said, if we take sulfuric acid and water, we get the phenol. If we just say if we take cuprous iodide or even potassium iodide, yeah, we'll get iodide. So it doesn't matter where we put our nitric group in this case. Okay, and then we know that now we could just put on our iodine. So we could take this, we could take I2. Yeah, so we could take I2 and some sort of Lewis acid. So I'm going to use aluminum triiodide, and I'll get the iodine in the, so I have a nitric group, we'll get the iodine in the meta position, since it is a meta, since NO2 is a meta director. And actually, let me correct what I said first. Yeah, I would put it in the spot of the alcohol, because we know how to get alcohol from diazonium salt, and we know how to add iodine to the benzene ring. So that was a correction. Okay, so now that we're in this state, now what can we use? Well, again, I'm just going to reduce this to aniline. Okay, so this becomes, I'm going to use sodium borohydride. Again, there's a plethora of reducing agent, which we already covered earlier on in the semester. And so we come to a structure that looks like this. We have our iodine, we have our NH2 group, yeah. And then from this, we use sodium nitrate, NaNO2, and HCl. And again, we generate the diazonium salt. So this becomes N2 plus, Cl minus, and we still have our iodine here. And we talked about how to get the alcohol. We simply add sulfuric acid and water, H2O. Yeah, so if we add sulfuric acid and H2O, we get the desired. So this is an OH, and yeah. So let me redraw this. I just messed up there. I didn't want it to look that bad. But we have our OH, and then we have our iodine, which is our desired product. Okay. So this is amido phenol. Yeah. So again, you could see the pattern. Anytime we have two anytime, and it's usually ortho para directors on the benzene ring, this is how we deal with it. We deal with it through diazonium salt chemistry.